In our last video, we've built a little tip calculator using Altova Mobile Together Designer, and we've stored all the data persistently on the mobile client device for that demonstration. But in real life, you very often will encounter situations where you obviously want to store data inside a database when you build your enterprise mobile solutions. So let's modify the previous example by taking the data about each restaurant visit that we've captured here and storing it not inside the persistent tree on the mobile device, but rather in a database. For that purpose, I have built a little database here. It's going to be running on a SQL Server. I've created a little table here called visits using Altova Database Spy, and we're simply going to capture exactly the same elements, a bill amount, tip percentage, tip amount, and so on, inside a database table as decimal values, integers, and so forth. And I've also added an additional column for a dining date so that we can keep track of how our restaurant expenses progressed over time. I've also added some sample values to that database table already. So there are 5 rows already pre-populated in that database with the exact same tip calculations that I used in my previous video. So let's go ahead and connect to that database from Mobile Together Designer. All I have to do here on the page sources on the right is add a new page source. And the page source I'm going to pick is a new database structure. We can leave everything else essentially set to default values. So when I do that, I get the familiar Altova connection wizard that you know from all of our other products. And I will pick a SQL Server database connection here using the OLEDB provider. And we will simply enter the server name here. We will use the Windows NT integrated security for now. Later, when you're deploying it to larger organization, obviously you can use your own database specific username and password, and we'll pick the database on that server. We can test our connection, and now I get to choose which database table I want to use in my example, and it's going to be this visits table here that I've previously constructed. When you do that, you immediately get a new data source here on the right hand side, and you can see that this data source contains a row set, and each row in that row set will contain all of these data points. So now we need to modify our example to actually work with that new data. We do that by taking this repeating table down here, and instead of having it be an element from the history in the persistent store, we can simply base it on the row. And we're going to have our bill amount here. We're going to have our percentage here, our tip amount here, and our total amount here. And then, as I mentioned, we've added a new dining date to the database. So let's populate that as well and show it here in the example. We're going to simply insert a new column to our table here. We're going to call that field date. And we're going to drop in the dining date here also as a label, and maybe add some formatting to that since we don't have that much space on a mobile device. We're just going to format it as an American date format here, but obviously you can use any other date format that you prefer. Okay, so now we've connected all of these elements from the database table with our table on the screen. You can also double check here under the history and see that all of these are now unbolded. These are no longer connected to any user interface element, so we can take this history in the persistent tree and simply delete it. And we should probably also start saving our sample here. So we're simply going to call that our tip calculator version 3. Okay. What else do we have to do here? We have a few error messages here. This one tells me that when I have a database page source, obviously our application cannot work in server access mode never. So we'll switch that to server access mode on demand, which will instruct Mobile Together to connect with the server whenever needed. And we will also have to make a few other modifications in order to make sure everything works correctly here. For example, the sum here that we previously derived as an XPath expression was a sum that we did over the persistent tree. We have to modify that and instead sum over the total amount here in our database now. So let's make that change. There we go. And now we can save that without validation errors for the time being. And now we need to modify what happens when we click the Save button. In the past, we've simply copied an entire visit element into the persistent history. We need to modify that a little bit, because as you can see in database rows, everything is represented as an attribute. So we have to convert all these elements into attributes, and we'll also have to calculate the dining date when we write that into our table here. So what we need to do is we need to modify the control actions for that Save button here. In the past, we've simply appended to the root history. What we will do now is we will append to this row set here. So instead of the root history, we will append to the row set in the database. And I should mention at this point in time that you have multiple choices when you're working with databases inside Altova Mobile together. Obviously, you can use straight database connections, as you can see here on the left side. So you can do the inserts directly in the database via db execute commands here. What we're going to show you here, however, is simply that you're going to modify the row set that represents all your database data in memory, and then update that by saving that row set back to the database, which is a very convenient way of doing that for small applications and all together. So what we're going to have to do here is we have to add a new row to that particular row set. So in order to create each row of this row set, we will have to iterate over the elements underneath our particular visit and create attributes out of them. How are we going to do that? We're going to use some XQuery code. So in this particular case, we're going to create a new element called row. And this element called row will be constructed in the following way. First, we're going to iterate with a for loop. So we're going to say for $i in, and where we're going to iterate is simply over the visit in the persistent tree. And we're going to go over all of its children. And for each one of the children, we're going to return a new attribute. And the way you do that in XQuery is you see return attribute followed by the name of the attribute, and we're going to take the name of the attribute simply from the name of our child element $i. And you also need a value for the attribute, and the value is in turn going to be the text of that element $i. So that's our for loop, and that will create 4 attributes to match the 4 attributes that directly correlate with the elements in our visit. But we also want to add another attribute. We can do that very easily in XQuery by adding another comma here. And the additional attribute that we want to add is going to be called the dining date. And its value is going to be derived by calling a simple date and time function XQuery that is called current date no time zone, since we're not interested in particular time zones in our example. And here is our XQuery code to create a new row element that has 4 attributes that match the elements in the visit, as well as a dining date attribute. And that should do the trick. So now we've added 1 row to that row set. The next thing we have to do is obviously use the save function here, and it defaults to my new page source db1. So we'll save the data back to the database, and it's good practice to immediately do a reload afterwards for the simple reason that sometimes we want have consistency checks, as well as the ability to see data from other users that may have been entered at the same point in time. So there we go. That's our new page actions or control actions for the save button. Now let's save that again. And there is another new error message. And the reason is that when we use the save function, we will have to add something called the original row set to our database source here. The reason is that Mobile Together is very intelligent when it comes to saving data back to the database. So we'll actually take only the differences in the data set and make those updates as necessary when it talks to the database. So now we can save that, and I think we're almost ready to give it a first try. So let's run our simulation and see what happens. As you can see, we see the database contents already in our list here. So on the 15th, we had an $80 bill with an 18% tip and so on. Those were the data values that pre-populated in the database when I built that on SQL Server. And now we can go in here and maybe have a 75, 60 bill today, and we stay with an 18% tip, and we hit the save button, and that's immediately added to our table here at the bottom with today's date. So we've easily converted that to a database example, and now to double check on whether that's actually true, we're going to switch to Altova database spy and run this query again in the database, and here's the new value that's been stored inside SQL Server. So you can see how easy it is to build a database-based solution with Altova Mobile Together. Thank you.